Hello, welcome back guys. This is Surendra. So in this series, this is the second lecture for Boolean algebra. So in this lecture, I will cover the properties of Boolean. So we have done all the gates, and I introduced what is Boolean algebra, for what it is used, and I said that NAND gate and NOR gate are universal gate. Why it is universal gate? Because we can implement any of the gate circuit, any of the gate using these two. So we will see how to implement any other gates using NAND and NOR gate. So in next lecture. So firstly continue this the property of Boolean. So first property is commutative property. So what is it? So a plus b is equal to b plus a into b is equal to b into a. Like we change the order, if we change the order of number, this will not change. Like if we change in any operation, so it will not change. This is called commutative property, and all the gates follow the commutative property. And second one is the associative property. According to this property, like b plus c, according to this property, like suppose we have to add three numbers. So firstly add b plus c, then a, and will be equal to a plus b, then add it to c, and same as for multiplication also. But this property is not followed by NAND gate and NOR gate. Why? I will give an example. Suppose I am taking for NAND. Suppose this is the symbol of NAND. So suppose I have to like these three bits. So I have to take the NAND of these three. Firstly take it by these two, and then take by this one. So 1 1 will be 0, and for 0 0 it will be 1, and take by taking this one. So 1 NAND by 0. So this will be 1, this will be 1, the result of this one will be 1, and the total result will be 0. So 1 is not equal to 0, then this property is not followed by NAND and NOR gate, these two gates, except all other gate like AND or XOR, exclusive NOR. So these all follow this property, but these two gate not follow. And then we will move toward distributive property. So according to distributive property, if like a into b plus c is equal to, then we can also write as ab plus ac. So this is a distributive property. All gate follow this property. So then we will move to some two theorems, and then we will go through the implementation of all other gate using NAND and NOR gate. So we have one more property called duality property. So according to duality property, when we duality property is used to convert positive logic expression into negative logic expression, and vice versa. So according to duality property, when in logical expression, when b plus sign is changed with dot and 1 is change bit 0, then it will be a dual of that function. If we change these two, so this will be a dual. So I will introduce what is means positive logic and negative logic. Suppose this is logic 0. We represent some voltage level for 0 and we represent some voltage level for 1. Suppose 0 is represented for 0 volt and 1 is represented for 5 volt. Then it will be positive logic. Why? Because 1 is greater than 0. And if we are just do reverse, so this one 5 volt for 0 and 0 volt for 1, this will be negative logic. And like we can say the minus 2 volt for this one and minus 3 volt for this one, so this is more negative, then this will be negative logic. And vice versa. So you can do by this, means if 1 is more positive than 0, then it will call positive logic, other than call negative logic. So duality property is used to change positive logic into negative logic and negative logic into positive logic. The 2 times dual of any function, 2 times dual of any function is the same function always. And if the 1 time dual of any function is same function, then that is called self dual. Self dual. So we have some example for duality property. Suppose we have to calculate the dual of this function. So how to calculate? We have to convert like this is the symbol. So the dot will be converted into plus and plus will be converted into dot, and there is no 1 and 0, otherwise if 1 will convert it into 0, 0 will convert it into 1. So the dual will be a plus b bar plus c into a bar plus b plus c into a bar plus c. So this will be a dual, and the again dual of that function will be like this plus will convert it into dot. So a dot b bar dot c plus a bar dot b dot c plus a bar dot c. So this is same function, so that is always true. So take another example. So guys, tell me what will be the dual of this one. Do separately. So a plus b dot will be plus will be converted into dot. So b plus c dot c plus a. Just simplify this equation. So here will be ab, this multiplied to both the ac plus this multiplied to both the. So b into b will be b, and bc plus multiplied into c plus a. So here if like we take common from there, so this will be b, this will be, so b 1 plus c, 1 plus c will be 1. So this whole will be b. If we take common from b and a plus b into b, so a plus 1 into b, so this will be b. So means these by these 3 terms we have b only. So b plus ac, c plus a. So multiply this by bc plus c into c will be c. So ac, multiply these two, ab plus ac. So ac plus ac will be ac. So bc plus ab plus ac. this is same as this one. So this function will be self dual, because the single times dual is equal to same function. So this will be self dual. I will introduce a new theorem called De Morgan theorem. According to De Morgan's theorem, the complement of any function will be like, if you have to complement any function, so just complement each and every element of that function and convert plus with dot and dot with plus. Like I will give some examples, like a plus b plus c. If we have whole complement, then it also can be written as a bar dot b bar dot c bar, and means complement each and every term. So like I will take an example of ab plus bc. So it can be written as ab bar dot bc bar, and it also can be written as a bar plus b bar into b bar plus c bar, and then you can solve by on. And like for a dot b dot c, it can be written as a bar plus b bar plus c bar. So this is De Morgan's theorem, and then we will move toward Shannon law. These laws are a little bit important. When you will go through K-map in Boolean algebra, all the expression can be solved by K-map. You have to just remember these duality property. Sometimes they ask only on rare 10% question will be based on this one. Other than all are for K-map. So we will study a little bit. That's why I am going a little bit faster.